Okay, continuing the properties of Laplace transform. The next property is the integration in S domain. Okay, this is the statement of the property. We know f of t has a Laplace transform f of s. Then uh, I divide the function in time domain by the variable t. So f of t by t will have its Laplace transform integration s to infinity f of s ds. Right? So if you divide the function by t, I have to perform integration on the other side. So previous property showed us that if you have a function f of t and multiply by t, that leads to minus 1 into differentiation of f of s. So multiplication means in differentiation on s domain, whereas division on time domain results in the integration. Okay, so the proof goes this way. So we start with f of s is 0 to infinity f of t e to the minus ast dt, right? In order to get the integration term coming up, so we can simply integrate s to infinity f of s ds. Okay, so that means even on the right hand side I need to integrate, so that is s to infinity, and there is already existing f of s which is 0 to infinity f of t e to the minus st dt, right? Outside we'll write a ds. Now we interchange the positions of integration. Okay, this is valid because it's a linear operator, right? We can interchange as far as we are sticking to the roots of integration, right? So 0 to infinity will come out and s to infinity goes inside, and you can see that the ds which was the present on the outermost side outside the bracket, it comes inside now. So s to infinity e to the minus st f of t ds into dt. So right, this means you can see that the integration is applicable only to the terms containing s. So e to the minus st ds we apply. So that is e to the minus st by minus t, because integration is happening with respect to uh, it's happening with respect to s, not with respect to t, right? So e to the minus st by minus t, right, into f of t dt. So when we substitute the value of s as infinity and s as 0, we can see the first term becoming 0 and the second term e to the minus st by minus t, where the minus cancels out. Yes, sure. Yes, sure. Yes, sure. Okay. You have any doubt? Yeah. Oh, all right. All right. Now it's recording, right? Okay. Shall I go to the okay. So we can see that 0 to infinity f of t by t e to the minus st dt. So whatever comes inside the bracket, you are taking the Laplace of that. So inside the bracket, I have f of t by t, which means it is Laplace of that function, which is Laplace of f of t by t. Right? On the other side, I have integration s to infinity f of s ds. So that proves the theorem. Okay. The next property is called as integration on time domain. So what is going to happen if you integrate on the time domain? So uh, this is pretty similar, analogous to the previous one. So f of t has f of s. Now you integrate it on the time domain. So 0 to t f of t dt means f of s by s, right? So we'll prove this. So we'll start from Laplace of 0 to t f of t dt. It's a Laplace we are taking, so I have to do the integration once again. So integration 0 to t, integration 0 to infinity, then integration 0 to t f of t dt e to the minus st dt. Right. So now we have two terms, right? First term is the integration f of t dt, and the second term is e to the minus st. Looks like a product. So apply, you can apply the first function, keep as it is. Integrate the second function with, and we get e to the minus st divided by minus s 0 to infinity plus right? 0 to infinity, right? I'll write that term e to the minus st by minus s, then f of t dt. Okay, so this when we substitute now, right? 0 to infinity, first term will cancel, all right, because e to the minus st is 0. Then when we put 0 to that, it's the terms cancel, right? So t is 0, plus 1 by s, 0 to infinity, it is f of t e to the minus st dt. So there is the f of s as well as divided by s, right? So that's the proof. Okay, so they are the important properties, right? Now using the properties, we'll try to solve some of the problems. Okay, all right. So first one, e to the minus 2t into 2 cos phi t minus sin phi t, right? So this is 2s, because uh, there I can see that e to the at outside, e to the at into some f1 of t minus f2 of t. That's fine. So first we'll write what is the Laplace of f1 and f2. That is 2s by s square plus 25 for the first one, minus sin phi t is 5 by s square plus 25. Okay, but I have to substitute s by s plus a, correct? Because e to the minus at is s. So every s has to be replaced like this. Correct. True, 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 true. Yes. So if you have e to the at, it becomes, sorry, e to the minus at, it becomes s plus a. So every s I am trying to replace by s plus a. So 2 times s plus 2 minus 5 whole divided by s plus 2 whole square plus 25. Right? Every term we are simplifying. Right? Once you get this final answer, you can see that this is what we get. Okay. So just go through this once and let me know if you are fine with that. Okay, let's move on to the next one. E to the minus t cos square of 2t, right? So we'll start with the cos square first, right? So cos square is written as, directly we don't have a substitution, right? So for cos square, uh, whatever, cos square of at or something, we don't have a direct Laplace transform available, right? So what we do now, we convert cos square theta as 1 plus cos 2 theta by 2. So that is half plus half cos 60, which has a Laplace, right? So you can see that we take the Laplace of that function over here, right? So that comes to be 1 by 2 outside. So there is a 1, which is 1 by s, plus cos 60 is s by s square plus 36. Is it okay? Right, now you apply the e to the minus t into cos square. Happens cos square. This means every s has to be replaced by s plus 1, because e to the minus 80, right? So we'll substitute half 1 by s plus 1 plus s plus 1 by s plus 1 whole square plus 36. Okay, all right. Now the next question is f of t is equal to 1 plus 3t into e to the 2t whole square. So 1 plus, right, we expand this first, right? So a plus b whole square, right, plus 9t square into e to the 4t. So we can see that there inside each term we have t into e to the 2t and t square into e to the power 4t, right? So you can find the Laplace of t, right, and multiply it by e to the 2t, because s by s minus e. Then t square I can find out Laplace of t square, and I will multiply that with e to the 4t's, right? E to the 4t means it has to be s s minus 4. So we are going to find one by one. So there is a one term 1 here, so for which we wrote 1 by s. Then 6t square e to the 2t has to be 6 times Laplace transform with s by s minus 2 should be replaced. So 6 into 1 by s square with s replaced by s minus 2. So 6 by s minus 2 the whole square. So then 9t square you have. So t square e to the power 4t means 9 times the Laplace of t square s by s minus 4. T square has, what is the Laplace of t square? 2 by s cube, right? Because it is n factorial divided by s to the power n plus 1. Right. So we substitute that. We got all the three terms now. And you will write the answer like this. So therefore, yes, correct. Okay, just go through this and let me know if you have any doubt. Now, so the next question is f of t is t times cos at, right? So cos at is a standard function, t is a multiplier for this here. So which property we can apply? T into something means which property? So we saw few properties, right? Out of which one you can apply? Cos at has something, then t into cos at should have what, right? How do you find out? Multiplication in t results in what on the right hand side? Time domain you multiply by time. No, time domain shifting means you should have t minus something or t plus something. That's not happening here, right? So you are simply multiplying by t. So we are multiplying in time domain. What happens on the frequency, or sorry, not frequency, S domain? What happens on the domain is my question. I'll show you the properties. Okay. So just check. This property says you are integrating on the time domain. That's not happening. I'm multiplying by t. Okay. So just check this. Here you are dividing by t, right? So here you can note that we are dividing by time. Okay. This is not the property. Now you come to one. You can see here. This is the property, right? F of t has f of s. Then t to the n into f of t. Now t to the n is 1 here. Okay. To the n into f of t means minus 1 to the n d to the n by ds to the n of f of s. Whatever f of s you have, it should be multiplied by minus 1 to the power n and differentiate n times. Okay. This property is called as derivative of s domain. Okay. Now we are going to use this property because we are multiplying by t on the time domain. Right? So cos at has Laplace s by s square plus a square. Since you are multiplying by t once, right? That is t to the power 1. The whole property changes to minus 1 to the n. Derivative 1, once you have to take a derivative of this term s by s square plus a square. Yes, yes. Okay. Right. Now it's a simple differentiation using a quotient rule. So derive the okay. You want me to show that part? Okay. So these properties are very important. Okay. Whenever Laplace, only this one you didn't write. Okay. Yeah. Please take down this. Huh. Okay. Okay. Please note. Okay, so just go through this problem once and let me know if you have any doubt. True, we apply quotient rule for differentiation. All right. In the next problem, we have t square sine 80. Okay, so the standard function which we are taking now is sine 80, which has a Laplace a by a square plus a square. Right, so since you are multiplying by t square, right, now the property changes to minus 1 square d square by d square of that function a by a square plus a square. So it means you should differentiate two times, right? D square by d square. So anyway, minus 1 square is plus 1, so we neglect that here onwards. It's simply, I apply d by ds once, so keep 1 d by ds outside and differentiate the inner term, right? That means you get s square plus a square into derivative of a numerator, that is 0, minus a into derivative of s square, which is 2s, whole divided by s square plus a square, the whole square. So, which reduces to, when we simplify, right? Since you are multiplying by 0, it simply comes to minus 2as by s square plus a square. Then, right, again I need to apply the differentiation. So, once again the quotient rule. So, the denominator comes as it is. Differentiation of numerator is minus 2a plus, right, 2as into. Then you can see 2 times s square plus a square into 2s divided by denominator square. So whatever you can take out and cancel, and after that we are getting the answer like this. Okay, yeah, just go through. I'll show you from beginning. Just go through this and let me know if you have any doubt. All right, then, okay, the next question is f of t is 1 minus e to the minus at by t. We can see that 1 minus e to the minus at is the function for which we can apply the Laplace directly. But if you have a divide by t on time domain, what happens on the s domain? What is the property? Which property we are applying? Time domain. Time we are dividing. What should happen on the frequency is a question. f of t by t, if you have, what should happen? Hmm. Yeah, when we have f of s, we know the pair. Okay, and if you have f of t by t on time domain, what should happen on the frequency domain or s domain? Sorry, not frequency. What should happen on the s domain? Which property, basically? That's my question. Let's check. So just see here, right? Is this the property? This is not the property, right? F of t has f of t integration. All right. Now you check this. F of t has f of s. Right. So if you have f of t by t, whatever f of s you had earlier, you need to integrate. So let's check this. So we have, see, I can see something by t. So whenever you see something divided by t, right, that something becomes your f of t. So I start with this. 1 minus e to the minus at is the actual function. I'll take its Laplace. That is 1 by s minus 1 plus, sorry, 1 by s plus e. Okay. This is my function. Now, if you divide this by t, right, whatever f of s you have, it should be integrated with respect to s. That's why I'm integrating here. Right. So when, correct. So when integration happens on time domain, something else will happen on the right side. Correct? Okay. Right. Now, so I need to integrate. So integration of 1 by s is log. 1 by s plus a is log s plus a. You need to substitute from s to infinity. So log a minus log b is log a divided by. So apply that. So s by s plus a. Substitute the limits. Okay. And when you put the limits, you get the answer like this. Okay. So that's the answer. I'll go back and show you the complete answer. Huh. Yes. Just go through these steps and let me know if you have any doubt. Hmm. Hmm. Directly, if you put it over here, it's like if I put infinity here, log of infinity, that is not possible, right? So just to avoid that, we try to take s out from the denominator. Now you see, if you put s over there, s is in the denominator. Infinity, if you put in denominator, term becomes 0. So that a by s becomes 0, but every whatever is inside the bracket becomes 1. So log 1 is 0. That's why you can see log 1 becoming equal to 0 in the next stage, right? Then s is substituting as s, means it remains as it is. Okay, so always log infinity does not exist, right? I need to make sure that doesn't come into picture. Okay, right. Now let's go to the next question. F of t is cos at minus cos bt whole divided by t. So as soon as you see the divide by t, this has this has to be the same property, right? I remove the t from that and I find the Laplace. So cos at minus cos bt, which is the numerator, find its Laplace as s by s square plus a square minus s by s square plus b square. So that means if you include the t in the denominator, this has to be the integration on the s domain. So whatever you got as the Laplace transform, integrate it with respect to s. Now s by s square plus a square has a when you integrate, you get half of log of s square plus a square. Similarly, s by s square plus b square has, right, half log of s square plus b square. So half is common, we'll keep it, right? Then apply s and infinity, right? So once again, when you cannot put infinity directly over there, right, it becomes infinity by infinity undefined. So we'll take s square outside from both numerator as well as the denominator. So it will cancel out a square, a square. So uh, when you put s as infinity, numerator has it a square by s square, which becomes 0. Denominator also has b square by s square, that also will be 0. Okay, so only n 1 remains over there. Log 1 is 0. That's why the whole term we made 0 here. Minus log of s square plus a square, s square plus b square. So ultimately the term remaining is minus half of log of this term. So minus half, you can take it inside. Minus inverts the terms, right? S square plus b square goes to numerator. S square plus a square comes to the denominator. And half means it is power, right? Root of something. So you bring log of root of this. Final answer for this question. Okay. 1 second, I'll go back. Just check the steps and let me know if you have any doubt. Now let's move on to the next question. F of t is equal to integration 0 to t into cos at dt. Okay, so here we know that whenever we integrate on the time domain, what should happen on the frequency or s domain? Which property it is? Hmm. Hmm. No, no, no. Integration with respect to time makes something else on the s domain, right? Both side you never see any integration, right? We'll go back. We'll check the. We are doing zero integration f of t dt. See this one here. We have integration 0 to t some function dt, which means you simply consider the original f of s divided by s. Hmm. Okay, that's a different property, correct? Yes. So now we can observe that in this question, the question itself says integral f of t is integration 0 to t into cos at dt. So t cos at is our function. I am different integrating that. So first I need to find what is the Laplace of t cos at. So how to find out t cos at? I wrote the answer directly, but you can verify it. Right? How do you find out this now? How do you find out t cos at? What is the technique? I know only. Huh, correct. So this is Miss. Hmm. Minus 1 to the power 1 d by ds of f of s, right? So that f of s is s by s square plus a square. When correct, right? So you perform that, then you get this answer. Okay. Now, since you have integration of this function, the rule says that simply divide the f of s by s. So this term what we have here, simply divide by s. So you can see one s extra here in the denominator. Okay, just verify that now. Okay. This is the question. F of t is equal to integration 0 to t e to the 2t sine at by t into dt. So we move from the innermost side of this problem to solve it because there are multiple properties existing simultaneously. Right? So start from sine at. Sine at has a by s square plus a square. Right. There is a divide by t. So whenever I have a divide by t, that corresponds to integration on the s domain. Correct? So we'll do that now. So s to infinity a by s square plus a square ds will perform. So a is outside again. So 1 by s square plus a square is 1 by a tan inverse of s by a standard in. Okay, substitute infinity and a over there. You get tan inverse of infinity is pi by 2 minus tan inverse of s by e, right? So 90 minus theta is cot, right? So that we apply and we got answer as cot inverse of s by e, right? This is for only sine at by t. In the problem I have further more, so this has to be multiplied by e to the at. So every s should be s minus a in the answer. So just replace s by s minus 2 now, right? Because e to the at a value is 2 here. So cot inverse of s by a with s is replaced as s minus 2. So your answer becomes cot inverse of s minus 2 by a. Okay. Furthermore, right? Is this. So in the middle we have a term called pi by 2 minus tan inverse of s by a. The property says that pi by 2 minus tan inverse equal to cot inverse, right? All right. Yes, yes, yes. Same rule. Huh. Sine cos can be replaced with the pi by 2 minus sine is cos, right? So something like that. Even the inverse trigonometric functions can also be related in the very similar fashion. We apply that. So now then, okay, for e to the 2t sine at by t, we got cot inverse of this as the answer, cot inverse of s minus 2 by a. But later on, I can see that in the problem, I have the integration coming up. To have an integration, this has to be 1 by s times, because you just have to divide by s for your existing Laplace. Existing Laplace in the sense it is cot inverse of s minus 2 by a. Simply divide by s like this. Okay, so that is the final answer for this question. You can see every property is being applied here, right? There is a simple sine function, then divide by t, then e to the at, then integration. Okay, right, I'll show you from beginning. Just go through this and let me know if you have any doubt. Yes, yes, yes. So you can find out which is the main function here to start with, like sine 80. None of the property says that multiply by sine this happens like this. So you can start from sine itself. Then you can even do the e to the 80 first. E to the 80 sine e to the power 2t sine 80. That can be done first. Then you use the divide by t, right? That also will give you the same answer. You can verify. Should identify which property to apply. That's all. That is important. Okay, then the next concept is the periodic function. So this is the rule to find the Laplace of any given periodic function. So if there is a function whose period is capital T, right? If a function repeats after say a time duration capital T, then instead of finding 0 to infinity f of t e to the minus st dt, this is the equation. F of s becomes equal to, right? I have to use a scaling factor as 1 by 1 minus e to the power minus s into capital T, where the period comes into picture, okay? Period into integration changes now 0, not 0 to infinity, 0 to t, because it's periodic. There is no meaning in finding 0 to infinity. Just find one period, 0 to t. Then the terms remain same. F of t e to the minus st dt. Okay. You can see that here I have shown the proof, right? 0 to infinity f of t e to the minus st dt is the required function. But we know that it is repeating. Correct. So since it is repeating, you are taking from 0 to t f of u e to the minus su du. Change of variable, that is valid, right? T to 2t, 2t to 3t, and so on, right? All for all the possible terms, you are calculating it like this. So that can be reduced to this form. N is 0 to summation. There are some, right? Many sums coming up. So 0 to infinity, starting from n t to n plus 1t, right? E to the minus su f of u du. Now directly we cannot proceed, right? We have to make a substitution. So put u as t plus nt, and which means du becomes dt. N into capital T is a constant, right? So we see that the lower limit is n into capital T. So when u was a term, this is the lower limit. When t is the term, now this is the lower limit, right? So u is n plus 1t means the t becomes capital T. So my limits will change now to 0 to capital T. I'll repeat. I can see that u is equal to nt is my lower limit. U is equal to n plus 1t is the upper limit. Right. But now I am actually replacing every u by t plus nt. Yes, in terms of t, I should write now because t is my variable, right? So u is equal to nt is the lower limit, right? Using u. What happens with the t? T is 0, right? Okay, then I have the second term which is the upper limit n plus 1t. So when you substitute that, the upper limit in terms of t becomes equal to capital T. Now we have f of u now, f of t plus nt. F of t plus nt is f of t, right? Because it is periodic. So we use that property. F of u is directly replaced by this. Okay. So coming back. So Laplace transform of f of t is, I have the summation. I have the same integration with the updated limits, right? And updated value for the function. Here I can see that integration is not applicable for n into capital D. Take it out. S into n into t in the exponential term will come out, e to the minus s. So this is what? 0 to t f of t e to the minus st dt, that is as it is, then I can see that the summation is again applicable for the terms containing n only, right? So which is the term contains that contains n, that is e to the power. So I can actually write that term as e to the minus st to the power n, right? Yes, so it's like a to the power n. Summation 0 to infinity a to the n is 1 by 1 minus a. So simply we'll write 1 by 1 minus a into, now this term integration 0 to t f of t e to the minus st dt remains as it is. So that's the proof. Okay. So the same thing which we had written earlier, right? Over here you can see then f of s is equal to this term. This is what we prove now. So if the function is periodic with the period capital T, right? Then you apply this rule. So now we'll solve periodicity property. All right, then we'll move to the problems. This is very important because most of the time the functions which we use are periodic in nature, right? So then we need to apply this property rather than applying the straightforward definition of Laplace. Okay, right. So you see here, f of t is a t square. General t square is not periodic, but they are mentioning that 0 to it is existing between 0 to 2 and it is repeating after that. See, f of t is f of t plus 2, which means it is periodic, correct? So I can see that the period is equal to 2. So if we identify that, okay, this function is periodic and the period is 2, definitely we can apply the periodicity property to find the f of s. So that is the equation wherein we can replace every capital T by 2, right? So you can see here that we substituted, here we are substituting, and we proceed. So which property? It's a t square e to the minus st means Bernoulli's rule, right? So keep the t square as first function, integrate the second function, then we get a minus sign into differentiation of the t square, which is 2t, further integration of the second term, that is this, then differentiation of 2t further gives you a 2, right? And further integration of e to the minus st by s square generates e to the power minus st by minus s cube. Are you okay with that step? We do that, then we substitute the limits now 0 to 2 for each of the term, right? First term becomes 4, then 0, then you can see 2 into 2 is, right, what we write, okay, the 2 goes out, 2 by s square, 2 into e to the minus 2s and 0, and lastly the term becomes 2 by s cube. uh, when you put 2 over there, e to the power minus 2s, and when you put 0 it is 1. So that is a substitution version. Once you substitute, then we go for simplification. Taking out the common and substitute simplification gives you this answer. Okay, just go through this and let me know if you have any. All right. The next problem is e sine pi t by omega from 0 to omega, and they mention that f of t is f of t plus omega. So omega is the period. Okay, so same technique. Just verify this problem. The capital T is replaced as omega in the equation. No, we observe that the omega is the period of the function. It has to be periodic, then only I can apply this function. Otherwise, you have a standard sine at, right? There is a sin 80. A by s square plus a square is what is the answer, right? But if it is periodic, I cannot apply that. This term, this one. Ah, okay. So this e comes out. That's all. Okay. And now the integration becomes a standard integral. Integration of e to the at. Okay. Sine bt. Right. E to the at sine bt. It's a standard integration. Correct. So we have a formula for that. I'll just show you that one. E to the at sine bt. Okay, just a second. Somewhere we had used it and I think I wrote it. Yeah, you can see here. E to the at sine bt. E to the at by a square plus b square. A sine bt minus b cos bt. Right? This has to be used. Correct, correct. Otherwise, it is not possible to integrate. Right? So we don't have any other alternative options there. So as soon as true, 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 true. Right? So because of that, we'll substitute that here. So just see here e to the at by a square plus b square, a sine bt minus b cos bt. So a is a minus s and b is a pi by omega in this case. Okay. So this step is fine, right? Okay. Yeah, yeah, yeah. Next step is we go ahead and try to simplify. Just try to see. Here we are substituting t as this is with respect to t. So yeah, first you substitute t as omega, then you put t as 0. Okay, then you verify. Okay, let me know if you have any other doubt when you proceed further. Okay, so the term in the bracket is a cot hyperbolic function. So after simplification you can see that you will get a cot hyperbolic. Mm, right, so that is a hyperbolic. This is okay, right? Shall we proceed further? Okay, next is, yeah, periodic function, but split up into two parts. All right, so 0 to a it is t, a to 2a is 2a minus t. It's actually a triangular wave. All right, periodic triangular wave with the period 2a. So 0 to a it increases, a to 2a it decreases. Straight line. It's a triangular wave. Okay, right. F of t is f of t plus 2a, means it is going to repeat after 2a. So the period of this function is 2a. So wherever I see a capital T, it has to be 2a. Apply the function, apply the property. So 1 by 1 minus e to the minus 2a, yes. But inside the bracket, the integration will be split up into two parts. Given function, yeah, function is defined in such a way that there are two parts. So integrate with there are two integrations to be performed. All right, it's just integration. Please go through this and let me know if you have doubt. All right. Hmm. Hmm. No, second also same thing. You can see 2a minus t as it is initially, then integrate the second term, then differentiate the 2a minus t, which is minus of minus 1. It's the same rule. These are the next steps. Please go through them. Hmm. Right. Correct. Correct. Yes. Okay. 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 1 by s square comes out, and then whatever you have is it. Uh, it's not written. I'll write and I'll share you. No problem. Okay. Yes, yes. Okay. I will share you. I will share you. Okay. Yes. This is fine, right? Okay. We have a few more problems left over. You please tell me one question. Okay. Of t is e sine omega t for this range. Okay. 0 to t. Yeah. So this is also given saying that it is periodic. Yes. Yes. Correct, correct, correct. Only that has to be done. And if you look at the signal, actually the signal is half wave rectified output. Only positive ripples you have. Okay, positive half cycle, then zero. Yeah, so half of the period it is there sine function. Okay, half of your period sine function means positive half cycle. Okay, then remaining half it is zero, right? Then it repeats, right? Okay, so that's the question. Yeah, that's the last question we have. Yeah, please try to solve this, and if you have any doubt, I will help you out. That actually finishes the concepts to be studied under taking out the Laplace of any given function. Okay, so that actually finishes. Let me know if you need anything else in this Laplace concepts, right? Because Laplace is too huge, right? We can actually solve the differential equations from them. Application part is actually there, right? If your intention is just to go through the basics, then this is fine. But let me know if you want to go through the other parts as well, where the application comes into picture. Then we can do that as well.